next set of directions ask us to solve for x. The triangles in each pair are similar. So when we have similar triangles or similar figures in general, we know that the sides are what? Proportional. So we can set up a proportion. So we need to label our triangles so that we can set up a proportion correctly. So let's take a look at this top triangle of 56 and 70. Which one's the small side? 56, which means 70 is our large side. Now let's take a look at the bottom triangle. Which one is the small side? 40. You can see that this side is clearly shorter than the other side. So we have 40 is our short side, and that means 5x plus 10 is our long side. So we need to set up a proportion. Again, the first number you start with is up to you. Once you've picked the first number, you have to set it up according to that. So if I start with 56, I need to put that over 40. I need to go back up to the top triangle. So 70 compares to 5x plus 10. I solve a proportion by doing what? Cross multiplication. Very good. So I've got 40 times 70 is equal to 56 times 5x plus 10. Now when I have a number on the outside of a parentheses, what do I have to do? Distribute. So what is 56 times 5x? 280x. What is 56 times 10? 560. We just have to throw that 0 on the end. Okay, what is 40 times 70? Very good. We can do 4 times 7 is 28 and put our 2 zeros on the end. So now we need to subtract that 560. So we've got 280x is equal to 2,000 what? 2,000 how much? 240. So now we divide by 280. And we get x equals 8. Very good. X equals 8. Now that side's not 8. X was 8. So 5 times 8 is how much? 40 plus 10 is 50. So that whole side would be 50, which makes sense. 40 compared to 50 versus 56 compared to 70. Okay, on 75, let's compare what sides match with one another. So the 36 side, is that my small or my large side? Small. I mean, it's the medium in the whole triangle, but we only have information about 2. So of the 2 that we know, it's the smaller one. Okay, what's the smaller one down here? 33x is the smaller side, which means 42 is my larger side, and 154 is my larger side. So let's set up our proportion. We've got 42 compares to 154. 36, going back up to the original triangle, compares to 33x. Now we have to cross multiply. So we've got 36 times 154 is equal to 42 times 33x. What is 42 times 33x? 1,000, how much? 86x. Okay, what is 36 times 154? 5,544. Very good. Thank you. So now we're going to divide both sides of the equation by 1,386 to find out that x equals 4. So x equals 4, which means if we plugged 4 in for x, that whole side would be how much? So 33 times 4 equals 132. So that whole side is 132. So 132 compared to 154 versus 36 compared to 42. It makes sense. Okay, we need to find x, so we have to use the x portion. So we've got 10x plus 6. What is that side in the smaller triangle? 35. Okay, let's go back to the large triangle. What would you like to use? So we'll use 80 for the large triangle, which means we're using what for the small one? 50. We could have done 104 compared to 65, but I would have also chosen the easier numbers. So now we've got 80 times 35 is equal to 50 times 10x plus 6. We know we have to distribute here. So 50 times 10x is 500x. 50 times 6 is 300. Okay, 80 times 35. What is 80 times 35? Thank you. So now we're going to subtract 300 from both sides of our equation to get 2500 equals 500x. And when we divide both sides of the equation by 500, we get x equals how much? Very good. X equals 5. So again, if we were to plug that in, 10 times 5 plus 6, so 10 times 5 is 50, plus 6, so it's 56. So 56 compared to 35, and 80 compared to 50. So our answer is reasonable. Okay, so the last problem of this type, we've got x minus 3 compares to what? 63. Okay, and then we've got 5 compares to 45. Very good. So now we have to cross multiply to solve our proportion. So 5 times 63 is equal to 45 times x minus 3. We have to distribute. So we've got 45x minus, what is 45 times 3? 135. What is 5 times 63? Okay, so if we add 135, wait, it's how much? 315. Okay, I didn't think it was 315. 315. So now we're going to add 135 to each side. 45x is equal to 450. So this should be an easy division problem. X equals 10. X equals 10. Okay. The next section asks us to state if the two triangles are congruent. And if they are congruent, we need to state how we know. So we need to talk for just a moment about congruence. So let's start out with our similarity conjectures. So we know that for similarity, we have 3 conjectures. We have side, side, side similarity. We have what else? We have angle, angle similarity and side, angle, side similarity. That's for similarity, but we're asked for congruence here. Congruence doesn't mean that the sides are proportional. Congruence means that the sides are exactly the same. So we need to figure out if we have enough information to determine if the sides are exactly the same. Now let's think through this. If we use side, 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 what does the ratio have to be if they're exactly the same? 1 to 1. So can we use side, side, side to determine if they're congruent? Yes, we can. We can use side, 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 congruence conjecture. We just know that the ratio has to be 1 to 1. Okay? Now, if we use side angle side, once again, the ratio of the sides has to be what? 1 to 1. Now, angle, angle. Let's talk about this for just a moment. With angle, angle similarity, think about an equilateral triangle. So in an equilateral triangle, all three angles are how many degrees? 60, because 180 divided by 3 is 60. So, can you have an equilateral triangle with sides of length 5 centimeters? Can you make an equilateral triangle with sides of length 5 centimeters? Can you make an equilateral triangle with sides of length 10 centimeters? Can you make an equilateral triangle of sides of length 20 centimeters? What about 30 centimeters? What about 40 centimeters? Okay, so if we have an equilateral triangle, and we know that we can have equilateral triangles with very different side lengths, do angles alone tell us enough information to know whether the sides are a 1 to 1 ratio? So if I know that all the angles are congruent, so think back to our equilateral triangle. I know that all my angles are congruent. That means my triangles have to be similar, so my sides have to be proportional. But just because I know, let's say I know that all of my angles are 60 degrees, so I know that I'm dealing with equilateral triangles. Does that tell me the length of any of the sides? No, it doesn't tell me the length of any of the sides. So I could have two triangles that share all the same angles, but for example, with the equilateral triangles, I could have one where all the sides are 5 and another one where all the sides are 10. Are those congruent triangles? No. So angles alone are not enough to prove congruence. Angles only tell us about similarity. So we cannot use angle, angle. It's not enough information to prove congruence. It will prove similarity, but think about it. You can have the same angles, but you can still stretch and shrink the triangle itself. The angles don't change, but the side lengths change. So angle, angle doesn't fix the lengths of the sides. So it's not enough information to prove congruence. Okay, so given what we've gone over so far, I want you to, on problem 79, scratch out 79. We'll go over this one after the midterm, but I want you to scratch out 79. The rest of them we should be able to do. So, problem 78. Right now we only have two conjectures for congruence. So let's look at it. Do we know that all three sides are congruent? Yes, because I have 2 marks here, 2 marks here. I have 3 marks here, 3 marks here. The third side is what? It's shared, so it has to be congruent. It has to be congruent. So we can use side, side, side congruence for 78. We can prove it with side, side, side congruence. Okay, for 80, what information do we have? We have 2 pairs of sides that are congruent, and we have the angle between them is congruent, so we can use what conjecture? Side, angle, side congruence. So we have enough information to prove our congruence there with side, angle, side congruence. Now in problem 80, we only have information about what? We have 2 angles. We also have information about the third pair of angles because they're what kinds of angles? Vertical angles, and vertical angles are always what, Manny? What do we know about vertical angles? They're always congruent. Very good. So, in this case, I have 3 pairs of congruent angles. But is angle, angle one of our congruency conjectures? No. So we're going to have to say not congruent. We can only prove similarity with angle. We know that they are similar. They are, in fact, similar because we have 3 pairs of congruent angles. We have more than we need. We have 3 pairs of congruent angles, so we know for sure that they are similar triangles. But we can't prove congruence.